Okay, so now that we have the embeddings, the next step is to perform the actual similarity search. So here's the prompt that we're going to be using for that. Integrate similarity search into candidate selection. When scoring candidates, query SQLite for published candidate IDs from the last 60 days. SQLite remains the source of truth. And obviously, you can tune this based on your use case, but 60-day works pretty well for me. Then query ChromaDB to find the maximum cosine similarity between each pool candidate and those published candidates. Add a similarity multiplier to the final score. So below 0.7 similarity, that's the safe zone, and we're going to just have a 1.0 multiplier. Above 0.85 similarity is the kill zone, so that's going to be a 0 multiplier, a hard veto. And between 0.7 and 0.85, that's the danger zone. So here we're going to have a linear penalty from 1 down to 0. Write tests for the similarity multiplier calculation. And again, these actual values are just kind of placeholders for now, just so we can get something working. And we're going to iterate on that shortly. I'll show you one technique we can use to actually come up with better defaults. For now, let's go ahead and implement this. Okay, and we're finished. Let's see. Selection. That's what we asked for. Updated scored candidate with a similarity field. Okay, embeddings. Get max similarity to published. Okay, let's take a look at the actual files. I forgot to commit the last round of changes, so we're actually going to see all of those here, unfortunately. Always commit after each step. Okay, get max similarity to published. Oh, I see. And we passed the published IDs in there. So the filtering for the last 60 days must be happening before we call this function. Okay, settings shouldn't be any new changes. Yeah, so here we go. So in the step, we now look up the published candidates from the last 60 days. And then those are the IDs we pass here into get max similarity to published. And then we call our ranking function, passing in all of the similarity scores. Okay, let's look at the ranking function. So we now have this similarity multiplier that looks pretty good. I'm a little surprised that it didn't automatically add a constant here for the thresholds, right? So we have this 0.7 in two places. That's it's a little bit ugly. I'm going to ask it to improve that. It's kind of the same up here, but at least here we don't have multiple locations where we reference those particular numbers. But here we actually do. So let's ask it to extract that into constants. So the scoring function, previously it already used freshness and fatigue. So now we also figure out the maximum similarity. And then based on that, we figure out the similarity multiplier. Okay. And then add that to the result. Yep, this looks good to me. Let's make this one quick improvement. All right, so I'm saying, please extract the hard-coded similarity thresholds of 0.7 and 0.85 into constants, so we can easily tweak those in a single place later. Should be a quick change. Okay, all done. So now we have our similarity safe threshold and similarity kill threshold. And then we can just reference those in here. Perfect. I'm going to commit all of this. Let's make sure the tests pass. Now we'll kick off a fresh run. Okay, we got an error again. The truth value of an array with more than one element is ambiguous. Use a.any or a.all. Kind of surprising that sounds like a pretty basic Python error. Okay, as always, I'll just paste this in here. Okay, fair enough. It's something related to the ChromaDB return value. I'll give it a pass. Okay, simple fix. So the not operator on a multi-element list or array from ChromaDB was ambiguous. Replaced with explicit is none and len equals 0 checks. Okay, sounds good to me. And we'll resume our last run. It's still running, but we can already see the results of the ranking, which is really what we're looking for. And yeah, we actually see the similarity multiplier here, right? So for most of these, it's 1.0. Now, I'm actually not sure what it's logging here, whether this is the max similarity or the resulting similarity penalty, the multiplier. I think it's the multiplier, because these actually don't sound that similar, right? So I'm thinking that these are probably considered safe. So no penalty. And then down here, we have the kind of linear decay that we're applying to anything in this sort of danger zone in the middle. And as a result, those get ranked very low, right? So this one gets a very strong similarity penalty. And as a result, the final score is only 1.3, even though the raw score was quite high and it's very fresh and only a fairly small fatigue multiplier as well. But it's really the similarity that dinged it and then pushed it to a very low score. So at first glance, this looks pretty solid. Now, we are going to need to dial in those thresholds, but this seems like a pretty good start. And the pipeline completed. Let's commit this fix here